everyone. Today we are going to discuss another LeetCode problem of the day. And the problem name is smallest integer divisible by k, and it is marked as medium on LeetCode. So first we will read the question, then we will move on to various approaches to solve this particular problem. Okay. So question says we are given a positive integer k. We need to find the length of the smallest positive integer n such that n is divisible by k and n only contains the digit 1. We have to return the length of n. If there is no such n, we have to return -1 in that case. Okay. So question says we are given a positive integer k and we have to find the length of the smallest positive integer. The positive integer n must be the smallest one such that when n is divided by k, it yields remainder 0. Okay, and n must be smallest, okay. Also n contains only 1, n contain only 1. So this is basically our question. So first let's take some examples so as to understand the question. So suppose we are given with k is equal to 1. So we are able to take the possible value of n. It could be 1, it could be 1 because we are allowed it to use only 1 to form our n. Okay, it could be triple 1, it could be 1 4 times, and it could be any number of times. And what is the answer that we got when we do the modulus of k with the n? For example, if we are given with an input k is equal to 1 and we have to find the least value of n for which the n is completely divisible by k. So if we take k is equal to 1, what is the remainder when 1 is divided by 1? The remainder would be 0. What is the remainder when 11 is divided by 1? The remainder will be 0. And same here in this case, the remainder is 0 for all. But we have to return the smallest positive integer n. So the smallest positive integer in this case would be this. And no, we don't have to return the integer n. We have to return the length of n. Means how many times the 1 came in that particular number. So here only 1 times the 1 is coming, and it is our answer for this particular test case. Let's move on to our second test case. It says input is given as k is equal to 3. So the possible value of n that we can have is, we can have either 1 1, we can have either 1 2 times, we can have either 1 3 times, and we can have any number of times. Okay, and we need to find what will be my remainder when I divided n by 3. That is 3 is k here. So when I divided 1 by 3, so my output would be 1. When I divided 11 by 3, my output will be 2. What will be my output when I divide 111 with 3? My remainder would be 0. So here is the number which satisfy this particular condition, that is n modulo k is equal to 0. So for that, in output we have to return the length of n. So the length of n would be, the length of this would be 3. So 3 is our answer for this case. Okay, let's move on to some interesting test cases. Okay, so we have our test cases k is equal to 9. Okay, so like there will be one doubt that from what range to what range we are going to include 1 in our previous number. So like this is one of the doubt then that you may encounter while solving the problem. Okay, so for that Actually, for that we have to just remind one of the concept related to the reminder. For example, we have n is equal to, we have suppose k is equal to 8. Okay, so what are the possible reminder that we can get when we divide any n with the k? So we can get either the remainder as 0, 1, 2, 3, 4, 5, 6, and 7. So these are the 8 possible remainder for this particular case when we divide any n with 8. Okay, so this gives us a clear idea that we have to append one. How many times we have to append one? 8. We have, in this case we have to append one 9 times, because for 9 times get we get different remainder in each case. We get different remainder in each case, and for that particular number we get first time the remainder as 0. The length of that particular n will be our answer. For example, k is equal to 9. If we see, we can have either 1 1, we can have either 2 1, we can have either 3 1, we can have either the 4 1. If till 9, if after appending 9 ones, if we are not getting the remainder as 0, then there does not exist any number n of ones only that is completely divisible by 9. So in that case we simply written -1. So 4 5 times, 6 times, 6 times, 7 times, and this is 8 times, and this is last one is 9 times. So when we perform, so these can be our possible values for n in this particular case, okay. So when we perform the n modulo 9, what are the possible reminders that we can get? When we take 1 modulo 9, the output will be 1. When we take 11 modulo 9, the output would be 2. When we take 111 modulo 9, so the output would be what? It will be, the remainder would be 3. And simply we can do the same for all the possible value of n's, and till this we are not getting any remainder as is equal to zeros. But here but when we perform here n modulo 9, we get our remainder as 0. Also, I think we are well known with the property of the divisibility of 9. That is, if we sum all the digits, and if the sum is divisible by 9, then the whole number is also divisible by 9. Here the sum comes out to be 9, and 9 is for sure divisible by 9. So it is our possible value for n. So here what we are getting in k is equal to 9, the output would be 9 in this case. That is, we have 9 ones in our n satisfying for this answer. Similarly, for k is equal to 7, when we take different value of n's 1 1 2 times, till how many times? Till 7 times 1. Okay, okay. So when we simply solve it, we get 1 as our remainder, we get 4 as our remainder, and so on. But when we solve for 6 ones, then we got what? N modulo 7, and then we got the output as 0. So how many times the 1 comes in our n? It is 6 times. So for n is equal to, for k is equal to 7, the output would be 6. Okay, so I hope you all got this particular uh, examples. So let us move on to our approach for this particular problem. Wait a minute. So there is a very simple approach. As I have already told you, we have to append one. How many times? We have to append one k times. Okay. So k times we have to perform the operation. K times we have to perform the operation. And as soon as we get any of the number n that is completely divisible by k, we simply return the length of that. Okay, for length we can do, we can initialize another variable, suppose l is equal to 0, and for every one that we are going to append in n, we simply doing the l plus plus, we simply doing the l plus plus. And also we have to perform the modulo operation, modulo with k. So for that we are going to use a property called as, by utilizing the previous logic. That is, for example, we have 1, we have 1 1, so we have triple 1. So if we are going to break it, suppose we have initialized our previous with some called as 0, so can we write 1 as 0 into 1 plus 1, and the output is confirmed to be 1? Yes. Now my previous would be 1, so it would be 10, sorry, it would be 10. Okay, so in this case my output would be 1 into 10 plus 1. Okay, similarly what I would do, I'll be like simply, if there are 3 digits, then we can take 2 digits, multiply by 10, and simply do a plus 1. Okay, so this is basically the thing that we are going to do k times. Okay, so for k times, okay, so firstly we are going to initialize a variable length as 0, and we are going to travel a loop, traverse like run a loop from, like suppose I is equal to 0 to k minus 1. Okay, and for every time, like suppose we have a previous called as 0, we call as a previous call as a 0, and for every time we are going to do the previous as previous multiply by 10, and we are going to append 1. Okay, so this we are going to do at the same time we are going to increment our length by 1, l plus plus. And at any time if my previous is, if when I do my previous, okay, here only we can look in, okay, no issue. So if I do my previous mod k, and if it is equal to 0, then we are going to simply return the current length, return the current length. Okay, we are going to simply return the current length. If till n we are not able to find any of the value of n that is completely divisible by k, so in that case we are going to return -1. Okay, so this is our solution. So let's move on to the coding part. Okay, so from today onwards we are going to code our solution in the LeetCode only. So this is our problem. So as I've already told you, first we will be going to initialize what? Firstly, we will be going to initialize the length that we have to return as the answer. Then we have to initialize our previous, and we have currently take it as 0. Then we are going to run a loop from I is equal to 0 to I less than, we have to run it k times now, so we have to run it from 0 to k minus 1. We can take k I less than k and doing I plus plus. And what we are going to do then, we are going to simply append 1 at each iteration, previous multiply 10 plus 1, and at the same time we are going to increment our length by 1. Okay, and for every iteration, because we need to find the smallest now, because we need to find the smallest, so in every iteration whatever the previous value that we got, we simply perform the previous modulo k, and if it is equal to 0, then in that case we simply return whatever is my value of current length. Okay, and if till k number of iteration, if it is not possible to find any value of n for which it is completely divisible by k, for that we simply return -1. Okay, so I hope, let's run this code. Okay, so there is a uh, okay, so this might arise because of this issue, because here also, because previous is an integer variable and it can get, might be the integer overflow. So there is a like basic property of modulo that we are going to tackle here, and that is previous. Okay, now we can do this. I hope it runs now. Okay, we can also check simply whether my previous is equal to 0 or not, because previous has already being modulo k by. Okay, so let's submit our code. Okay, so it got accepted. Okay, so there are further optimization. However, this is also our optimized code. If we talk about the time and space complexity, so the time complexity for this code would be order of k, and the space complexity for this would be what? It would be big O of 1, because here we are only taking the space to initialize two variables, that is length and previous. Okay, so this is my time and space complexity. However, like we can also write the code as suppose we are not interested in initializing any length variable, so we can do one simple thing, that is we can run our loop from 1 to k, and as soon, and there is no need of length here, if we got our previous is equal to 0, we simply return whatever my I, because here the I also denotes the number of iteration as well as the length. Okay, so simply we are going to run our code. Okay, let's submit. Okay, so it got accepted. Okay, and yeah, I hope you all like this particular solution. If you have any doubt related to this particular question, you can tell me in the comments. I'll happy to answer all of your doubts. Thank you.